So, ladies and gentlemen, welcome back, and we're going to be looking now at the Mars project, exploring life on Mars. If I could just advise you that this bit is being televised for the Finn TV as the whole program, so if you've missed something, there will be an edited version appearing on the program later. So, welcome to that one. So, will there be life on Mars? And will life coming from us, or is there going to be life already there that we're going to dig up and find? We're going to talk about some of those things here. Now, across here we have Dr. Adriana Marais. She's a theoretical physicist. She's the head of innovation at SAP Africa, SAP Africa, has a PhD in quantum biology, and is an aspiring extraterrestrial. And we're going to be looking, because you're on that the Mars One project, so we're going to be hearing a bit more about that and what it's going to be like if you get there. And then Antti Perttila, who is the principal lecturer at Tampere University of Applied Sciences in Finland, but is also working on NASA's EPIC Challenge program, which is aiming at really looking at a permanent habitation on Mars. So, Adriana, I want to start with you, actually, if I can, please, because it's a bit odd when you meet somebody and say, what do you want to do? And I'm an aspiring extraterrestrial. Tell us how you've got this title, really, and what the plan is with Mars One.
Well, I mean, I think space has never failed to fascinate. If we just look at children, I give a lot of talks at schools and businesses and across the board about this. And the idea of exploring beyond our planet Earth never fails to fascinate. So what exactly is it about, planet Mars in particular? Well, it's the next door neighbor planet, and it's really the logical place to begin our exploration of the rest of the solar system. So we're living in an unusual era. I think sometimes because we're living in it, we don't deeply appreciate just how unusual an era we are living in. So the Earth is around 4.5 billion years old. And we have gone through multiple extinction events. The oxygenation of the atmosphere around 2 billion years ago was one of them. And the era we're living in now is both extremely exciting and also extremely terrifying at the same time, because the kind of changes that we are inducing and observing around us may be unprecedented. So there are multiple motivations for exploring Mars. I would say, personally, I believe in doing things for the right reasons, and I am curiosity driven. So I think we need to do this out of a spirit of knowledge creation, out of a spirit of celebration of where we've come from and what kind of future we are trying to create. Another aspect of that curiosity is to do research. So, in parallel to that curiosity of just experiencing what it's like to live on another planet, which I've dreamed about since I was around 3 or 4 years old, is the research that we'll do there. So now, having become an adult, I've kind of qualified that excitement and curiosity in terms of what I think will be the most profound possible contribution of science to humanity, and that would be to detect evidence of life off of Earth. I believe there is life off of Earth. I believe we just haven't developed the capability to really identify it yet, and Mars could be our first instance of where we detect. Maybe it's ancestral to life on Earth, maybe it's related to life on Earth, but I believe there may be something below the surface, and the discovery of that will be the most profound possible discovery for life on Earth in terms of adjusting our consciousness to our place in the universe, that we are not alone, that other life exists out there. So that's really my sort of research aim of getting to Mars. But on another level, and that's the positive side of it, there is a negative aspect about why we need to get to Mars. So humans are explorers, but in history, typically we've done exploration out of desperation. We have a short window period now where we can do curiosity-driven exploration in terms of sending people to Mars and establishing an off-Earth settlement there. If we wait too long, we may find a scenario where we're doing it out of desperation and where we cannot get the resources together to in fact achieve this grand goal, which will literally take the whole Earth to get it done. Each and every one of us, 7 billion on Earth, needs to believe in it, need to contribute to it, and this can ensure that we have a backup plan. I mean, it would really be a waste of 4.5 billion years on planet Earth if we allowed ourselves, in spite of having the capability now to get off planet Earth, not all of us, but just some of us as a backup, it would be a waste of 4.5 billion years if we did not maximize our use of our technological capabilities, because there are many extinction level events that can happen, and 99.9% of species that have ever existed have gone extinct because of environmental changes that they are not able to survive. So I think we have this window to do this in a spirit of inspiration, passion, curiosity, and exploration. And I think therefore we should do it, because I don't see any reason why not. So very broadly.
So, Adrian, I know Mars One is just one of the potential options, but you saw something about that and signed up. I mean, how did that process go to get on to Mars One?
So we've got many entities developing, well, not many, maybe we need more, but there are a few entities developing hardware. But in terms of crew selection and training, Mars One is currently the only entity involved in that process, besides NASA and other entities which have been planning to send crews since the 70s. I believe I wasn't around in the 70s. So it's time where private companies have stepped in and tried to fill some gaps in this process. So the Mars One project was established in 2012 with the aim of establishing settlement on the surface of Mars, demonstrating livability so that others would follow. So in 2013, I read about it, volunteered. 200,000 applications were received, and during the past 5 years, it's been narrowed down to 100 of us, and we plan to have another selection round in the coming year, hopefully, where 24 will eventually be selected to embark on a training program of around a decade, hopefully less. That's completely dependent on the hardware developers, of which we are not one. We are not a technology company as Mars One. We are purely looking at the crew. So I'd say the major asset of Mars One currently is the 100 of us who are unified in our belief that this is possible and that we have what it takes to be those first Martians that prove and demonstrate livability on the surface of Mars.
Have you met any of the other hundreds yet?
Sure. So you may be wondering, are they completely crazy? Are they visionary? I've met sort of dozens of them, let's say, and we do interact online regularly. But amongst us are researchers traveling to Antarctica regularly. Surgeons doing training in zero gravity conditions with respect to being a surgeon in the space station. Researchers like myself interested in the origins of life and whether or not life can be sustained or detected on the surface of planet Mars. And last and most certainly not least, engineers of all types, people who believe they can fix, create, make, break any piece of equipment, because of course that equipment is all that stands between us and around 30 seconds left of life. On Mars I think it would probably take around a minute before you would breathe in a breath of carbon dioxide, fall down and die of hypothermia before the low pressure caused your organs to fail. So equipment, highly important. People who can maintain it, extremely valuable.
Okay, which brings me nicely on to Antti, and you are an engineer
Yes, I am, yes.
by background, and there you are at the university looking into what is needed for Mars. What have you found so far?
Yeah, I just noticed that it's almost impossible to go there. So that's my first idea, first thinking. But then I'm not so hopeless anymore. I mean, we can let's say have this as a global effort this and exactly this Epic Challenge program what was started by astronaut Charles Camarda at NASA. He wants to expand the innovation creation as a global activity, and his aim is to have 30,000 students on board to try to find innovations there for Mars program. So because currently, if you just think about numbers, so if we want to send Ariana and her friends to Mars one day, then we have to send something like 1,000 tons of material from here to Mars. 1,000 tons. The International Space Station weighs something like 400 tons. It has been built during 20 years, I guess. 20 years. I don't know how many tens or missions have been done for that, but it's on a LEO. It's very close to Earth. If you have to send this material to Mars, then it's I don't know. It seems to be impossible. But this Epic Challenge program is trying to find, for example, solutions. How can we use the resources we have on Mars? That we don't need to, for example, bring water with us. That we can create water from ice, what is there underground on Mars. So it is very possible. And then also there are some gases in the atmosphere of Mars what we can use. And maybe we can send some automatic factories there before astronauts will go. The factory make for example, water for astronauts and start to grow some vegetables, so potatoes like in the movie we saw, which was quite stupid movie by the way, but it has some basic good ideas. So we are having this epic challenge. We have in Finland something like some 300-400 students working on these issues, and they are exactly picking one challenge. For example, growing food on Mars, and then making a project on that. And then they are simulating, doing tests, and even growing some stuff, and then showing that okay, this could be maybe working also on Mars environment. So we are having this food, and then we are having this radiation protection, and then we are having this, like was very interesting talk about this capsule to send to somewhere, maybe to Mars as well. So like I asked once again, what is the weight? Because the weight is critical. But we can have some kind of umbrella type of things as well. What we, for example, fill with some gas or something that it doesn't weigh much, because the weight is crucial. Or maybe we can use the material, the soil, what is there on Mars, and maybe we can just then 3D printer and then start printing our houses from the material what is there. So that is maybe the main idea. We use the resources what we have there. And then also the mission itself is interesting because the distance is so huge. I mean, you can't have any like remote control systems from here to there, because the RF signal takes something like 20 minutes to travel from here to there. If you send it, okay, do it this way, okay, it takes 20 minutes one way, 20 minutes back, so it's almost 1 hour. You notice, did it happen or not? So everything must work automatically. Must have backups there, and we can't rely on anybody on Earth when we are doing something on Mars. So that's like using the resources what is there, and having all backups and all things there what is required. So yeah.
It won't work because of money. Is the
money
you're talking about the
yeah.
weight? You know, presumably if you could send 10 units up there, you could carry the cargo that's needed to go. Or is it that we don't actually know enough yet about what the surface of? I know we've successfully had Mars rovers going in there, digging about and sending back information that I guess is incredibly important to the things you're thinking about, Joanna. And is that what the problem is? Is it money? Or is it knowledge?
Yeah, okay. I don't know if it's money. If you think about, like in this exhibition, you have so many military things being shown, and there is money if there is want. but yes, the weight is to send 1,000 tons from here to there, and then okay, it's also money. If you think about Curiosity, the rover, which is moving there on Mars currently. It cost about 5 million euros or dollars per kilo to send it from here to there. Then you can calculate, okay, 1,000 tons, okay, times 5 million per kilo, so it's quite a lot of money, but still it's not so much. Somebody has calculated at NASA that it's not only sending this material, but also some research and development work is required to make new technology for that mission. So that is also there, and then they estimate that it is 1,500 billions about what would be the total cost. But like when we had this moon mission in the 60s, was it? Quite far a long time ago. Then during that mission, or before that mission, a lot of research and development work was done, and new materials were invented, like I guess Teflon was one of the, Kevlar was one, and then also digital camera. Digital camera basically was created for moon mission. First they sent some rockets to moon, and they took pictures out of the moon and the landing site where Apollo finally landed. They created just, we have to make a digital camera. Think about it. There was a digital camera available, and they had to make it, that they were able to send pictures from moon back to Earth. So I mean, it's not only that we like waste the money. So for sure, we will also create some innovations what can be used for mankind later.
Quite like this to be an interactive session, so if there's any questions, one here, please. There's a microphone on its way. Thank you.
Thank you. I'll take the... Can you hear me now? Okay, great. First of all, I'm not a scientist, but I have to tell you, I am so inspired by the concept of the mission to Mars. What even I find more inspiring is that it is a one-way mission for these astronauts. And for a moment, while I was listening to the conversation, Dr. Petula, the way you're describing how much it's going to cost, for a moment I thought if I was the person who's going to sign off on the budget to do this, I would probably not sign off on it. But then you close your statement with the fact that so much of innovation gets created through the process of attaining that goal. To what level do you think, whether the goal is achieved or not, is it still worth engaging and trying to attain that goal in the near future?
Yes, for sure. For sure, we must do it, and I'm for it. So that's very important. And by the way, something what I didn't mention, which is relating to this, is that NASA they have some ideas or some similarities what happened during moon mission. So there was a huge interest increase among students for STEM subjects, which means science, technology, engineering, and mathematics. So they are hoping to get a similar kind of interest increase, and having this like globally, this kind of huge interest, then certainly these young people can create new things, not only for this Mars mission specifically, but also for other things, like we have problems with our environment here. And by the way, something I did mention, but sometimes I feel a little bit sad because I think so. I believe that there has been oceans on Mars, for example. There has been atmosphere on Mars, and now it's basically very thin and only CO2. So is that future of Earth as well? Because it seems to be like that. CO2 is increasing all the time, and so on. So is this like how Mars used to be some billions of years ago? It was like Earth, and now it's there. So could we also learn about that? Think about that if we make wrong decisions here, is Mars our future? Okay, but in other hand, if we can make the settlement on Mars or somewhere else, and then maybe we can start new life there. I don't know.
Jeremy, can I take up to you? So is it a nice to have, or is it a need to have?
Absolute necessity, in my opinion. We've been exploring since day one. There's evidence of bottlenecks where some group of 10 or so humans survived a massive environmental catastrophe. Genetically, we can see there were these bottlenecks. I believe we may be encountering one in the future because the current trajectory on which we are currently progressing, it does not look good. And I think we need to use our technology both to take that bigger view perspective and realize that we may have passed the ecological tipping point already. Typically, we would comfort ourselves by saying, evidence in the last few years of my life shows that tomorrow will be no different from yesterday. But at some points on an exponential curve, that starts to change drastically. We still have time now to do this in a spirit of joy and exploration and celebration of humanity, I believe. And I think we need projects like this to get us excited about the future. In the past, it's been possible to move to new continents. I'm a 12th generation French Huguenot on one quarter of side of the family. My ancestors departed from France to escape religious persecution and potential death or definite death in the 1600s. So this family, the Marais family, the same surname I keep, traveled several months into the unknown on a one-way trip to assist the Dutch with the establishment of agriculture at the Cape Colony in Cape Town. I'm from Cape Town. So I still live there. You know, a one-way trip out of desperation is not necessarily ending badly. I love living in Cape Town. If you've ever visited, I'm sure you would agree it's not a bad place to be. And this is the result of several, tens of generations later after a massive sort of move from one place to another. And there are many parallels between moving intercontinentally by ship and moving interplanetary by spacecraft that we face today. It's a several-month journey into the unknown, but arguably we have more information now about the surface of Mars that we will hopefully arrive at than those early explorers or refugees did in terms of jumping on ships and crossing oceans to arrive at new continents. I think it's extremely crucial, though, to do it out of a spirit of a celebration of humanity, because I don't use the word colony, if you've noticed, because coming from South Africa, this word has extreme negative connotations. And our colonization of various parts of the planet has not always been purely, of course, far from a purely positive thing. So I think when we go to Mars, it should not be out of desperation. I think it's important that we get it done earlier than that, so that we can, joyfully get together as a society and say this is our next grand step into the space around us. We have time to do that now. I believe it would be possible, hopefully, in my lifetime. I mean, there's a lot of work to do. I agree with what Antti has said here. There's a lot of work to do. It looks impossible, but we've achieved the seemingly impossible before as humans by working in teams, collaborating, and just believing that it's possible. As Nelson Mandela said, we celebrated, was it yesterday or the day before, 100th anniversary since his birth. It always seems impossible until it's done. I think that's what humans do, is achieve what seemed to be impossible through our intelligence and our capability to develop technologies. And I hope that we can do this in a spirit of celebration. Perhaps the moon landing was not sustainable in terms of us not having gone back since 1972, because this was not done in a spirit of celebration. This was done in a spirit of a demonstration of power. And this kind of push to do a political muscle flexing activity has clearly not resulted in a sustainable sort of space program to the extent that we may have hoped, that this cohort of students who registered in STEM degrees in the 70s may have hoped. So indeed, I think this is an excellent way to get us excited about what humanity is, excited about our technologies, and to go forth with a spirit of exploration while we still have that possibility.
But is it not so that you need a bit more than that to get the funding? Because some people generally don't pay for the spirit of exploration unless there's a financial return somewhere at the end, and whereas desperation is more likely to get money thrown at it. How do we inspire the people with the money to fund what you want to do by going to Mars?
And that's the $1.5 trillion question. So there's several milestones, I think, that we could look at before we send crews to Mars, and we're planning this for 10 years, so there's not a lot of time in between. I mean, I'm hoping it happens in my lifetime, of course, hoping to be one of these people. But I believe that, so satellite debris in Earth orbit, this is one monetizable activity that we could start to become good at in terms of being able to retrieve this debris, both to clear the path for the launch of further satellites. We're seeing lowering of cost in terms of launching. We're seeing India launch sort of 130 nanosats in one launch. So increasingly, more countries are going to want to have access to having satellites. So we need to start clearing up that space, and I think becoming adept at gathering this debris, maybe 3D printing satellites in orbit. This is one activity that's monetizable that could be a stepping stone. A base on the moon, we're already seeing China and Europe look at this, and perhaps Mars could be next. So we can look closer to home in terms of monetization.
Okay, Antti's going to respond, and then we're going to go to a question over there. Antti.
Yes, about getting money. So I think NASA is quite good on that. So they always have like news that maybe there's life on Mars. Maybe we Curiosity found something, some molecules which could be some kind of evidence of life there. So that's always, I mean, we human beings are interested in life, especially if the life is not next to us. If it's very far away, then we are interested in. So I think that is something that if like I think so sooner or later we will clearly see evidences on Mars, because for me it's very natural that there has been life there.
Yes, thank you. Look, this is very interesting. Firstly, I'm not that sure that that you're really buying sort of the backup for humankind. At some point, the sun's going to expand as it collapses, and Mars will be consumed by that event. So I'd have thought we'd be better spending our time sort of sorting out carbon on planet Earth, coming up with technologies to minimise the effects of carbon. There's all sorts of technologies in the mill. But I've just got a question about the practicalities of being on Mars. This terraforming idea that Elon Musk has talked about, we start modifying the atmosphere, is that really practical? And secondly, is the Martian regolith, which is high in perchlorates, is that really a good soil to be growing things in?
Yep, so they've been experiments done in Martian analog sand. Thanks to the Curiosity rover, we have an idea of the composition. And the plants that have been grown in this analog sand, of course, we haven't done any sample return missions from Mars, have been shown not to maintain these toxins and are safe to eat. A Dutch research group, I forget which one, has done research on this. SEED, I think the project was called. In terms of terraforming, I think this would be the long-term goal, and this is why we need to get going on this project. This is certainly not going to Mars does not preclude all of the research projects that are necessary on Earth. It's not the case that we only have $1 trillion left and we need to decide whether to save Earth or go to Mars. That's not the case at all. I mean, US military budget's like $1 trillion every year. Forgive me if I got the numbers wrong. So this is certainly not precluding all of the investigations that need to be done. The fact that a handful of people and 1,000 tons of metal and other equipment will leave Earth certainly doesn't make any kind of dent in what activities need to go on Earth. When the sun does envelop Earth, we may have a few extra years on Mars, but by this time, 1 billion years from now, or perhaps hundreds of millions of years from now, we need to practice getting to Mars before we can even think about going interstellar. The propulsion systems need to be developed. We have to, use this as our training ground to eventually get out of the solar system, because, as you say, if we're looking long term, the sun will eventually go red giant and it won't be possible to live on Earth or Mars. But this is a stepping stone to get further out. And terraforming Mars will be hugely resource expensive. We will rely on Earth to be able to terraform Mars. We will not be able to develop the industry purely on Mars initially to do such a large-scale activity as terraforming a planet. Arguably what we're doing on Earth right now is some kind of practice of how to change global conditions. Emits a lot of greenhouse gases and you can increase the temperature. This is in fact a clue of what could be possible on Mars, because it's -50, -60 degrees Celsius on average now. We need to warm it up first in order to have liquid water present to sustain life as we know it, at least. So Elon, as we know, has suggested nuking the poles, which are largely carbon dioxide containing, to release this carbon dioxide on a scale greater than the 96% of atmosphere at 1% of sea level pressure, which is currently present. But I think we need to get a lot smarter. Perhaps genetically modifying certain bacteria will be the way that we can use the resources on Mars to achieve such a grand aim as terraforming. But I think we certainly need both settlements in place to be able to do this. The sooner the better.
I feel compelled that I have to ask this follow-up question, and basically because of the question that you asked, Alan, and it's the $64 probably trillion question. How do we fund this? And there seems to be a bit of a decisions whether it's worth the cost or not. And I'm gonna take a crack at it, and I think how it can be funded. One, Dr. Pettula, you just mentioned earlier on how this could be part of inspiring the youth in taking up sciences. Now, if this is a mission for the benefit of humanity and Earth, and the youth are engaged, and then we factor in the what I call the lip service of corporate social responsibility that we see today on a global scale, and the demand by the public and the youth that we need to see more than just lip service. Show us you are investing of what is relevant, not what is sellable. Then I think you will see a greater adoption rate of more funds coming in, because the fundamentals, in my opinion, and I'm not a scientist in outer space, our expertise is somewhere else, the fundamentals is not whether we get there and we deliver. The fundamental is the journey and what benefit we get from embarking on that journey. That's my 2 cents. I probably would want to put it to your panelists to give their thoughts on this, please.
Yeah, I think so. This is really really right, and that's the idea of this epic challenge. That let's make this global, and if this young people at universities and schools can take this and think that this is important, that they are interested in that, and then things can be changed. And then like we have social media. If we would have like we had Me Too here in Europe, but I don't know, also in the US. So many things can happen quite easily. We may think that it's not possible at all, but if you can get tens of thousands, 100,000 or millions of people to say that, okay, we must, instead of putting money to military, we can put 10% of that money to this space mission exploration. So I mean, things can change, really.
200,000 people applied to Mars once. So, I mean, there's already a lot of people, and presumably none of them were old pensioners like me. They were mostly young people, I guess, were they? Or do you know?
The average age is 30s, and typically astronauts would continue going to the space station into their 50s or 60s. So it's really about expertise and sort of psychological stability, more than being, super strong. And we will have rovers, and it'll be 38% gravity on Mars, etc. So age is not such a huge issue. I think 200,000 is probably low. I think if they had marketed for longer, more people would have applied. So my mission in life, besides doing my research and working for SAP, is really to spread the word about this. And typically 1 out of 100 or so people in the audience would put their hands up. Maybe we could have a show of hands here.
Who
would be willing to
Who'd
go
like
to Mars?
To go to Mars?
Let's say it's
One-way
not
trip.
Well, of course we
Mars.
have a biased group here. Fantastic. So I think more than 200,000 would be prepared to go. Elon Musk, and as a South African, I must, and I'm sure you are aware of it, this year in March launched the Falcon Heavy for the first time, and for the Mars One vision, this 64 metric ton capability is sufficient for our purposes of sending the minimum possible mission to Mars, which may not be sustainable, and I'm sure you have many reasons why sending 50 tons of cargo with 4 people is not probably going to work, but the demonstration of livability is really our key endeavor, and we're hoping that others would follow. Elon Musk, on the other hand, with SpaceX, is planning to do the next phase after the Falcon Heavy, which is the BFR, the big rocket, his acronym, not mine. So this big rocket will send 100 people at a time, according to their announcements. So he's really planning to launch hundreds of people constantly as possible over the next decade or two. SpaceX was, of course, founded for the primary goal of settling humans on Mars. We've got Jeff Bezos as well, talking about doing it step by step and having the moon base as a precursor to ensure sustainability of something that's more difficult and ambitious, such as settling on Mars. But I think with these two billionaire, high-powered individuals behind the Mars mission, it's interesting that we have this sort of coming together of people with resources, private individuals in this case, who are going to make this happen. Maybe this is an individually driven thing in the end. Maybe each and every one of us needs to decide whether this is something we personally want to support or not, and whatever structures emerge, maybe that's what will get us there.
And if I may say something about cost, so the cost to send, like I said, that 5 million per kilo to send Curiosity to Mars was the money what NASA spent basically. But now we are having SpaceX, and SpaceX is able to send things much cheaper. Is it only 1/3 of the price or 1/4?
They're hoping.
Fourth. I mean, what they have to pay. And now also I don't know exact numbers, but also China is having a big rocket. I don't know if it's functional yet, but they are planning to have it at least. So I guess the prices will decrease because of competition. So
and competition, are we going to end up again? It's going to be that race for Mars. Who's going to own it? Are we going to get protectionism creeping into this? Is it going to be private, or is it going to be American or Chinese? And does the SpaceX get there and then get blasted out the sky by the bad guys or something?
Yeah, nobody knows. But I wish to have it like a common, owned by whole human or mankind.
I think this is why I'm happy that perhaps NASA did not get it right in the 70s or 80s when they planned to send crews to Mars, because then it would be US. If a nation sends the first mission to Mars, we naturally land in a situation that we may want to avoid. If it's going to be individually driven or privately driven, then we have the possibility, out of a spirit of capitalist competitiveness, I don't like saying that's the spirit in which it's done, but if we do have private companies going, I think we have more chance to set up a scenario like Antarctica, where we have different bases belonging to different entities, but collaboration is the name of the game, because it's a tough environment to survive in.
Okay, one final question down here, please.
If it is individually driven, how do you then make sure that, say, another group goes, you don't end up with just more issues of who owns what in Mars? Because obviously if you have two different companies in Mars, SpaceX and Mars One, who owns what? Have you thought of anything like that yet?
I mean, personally, I would do away with ownership altogether. When you are struggling to survive, collaboration is the name of the game, and ownership just doesn't make any sense. I mean, Mars is a desolate place, but it's also desolate ideologically, and that's part of the motivation for getting there, is to start from scratch, building a society, keeping what we maintain as being necessary and relevant and beautiful about that society, and doing away with the things that are extraneous and not beneficial. And in my opinion, ownership would be one of those things that we would do away with, money being similar. Resources are all that matters, human resources and physical resources. And an economy structured around sharing these things in a way that makes sense would be the way to go. So certainly SpaceX and Mars One would not be in competition with each other, because we rely on them for the technology. We are the crew who would be partnering with them, and I believe these kind of partnerships, it's a big planet, so people would presumably land in different locations, but I hope that we can do away with ownership altogether.
Yeah, if can say that luckily this is so epic challenge, really, so huge that there isn't anybody who can do it alone. So we have to work together.
We are not alone. Can I just take a show of hands? How many people think we will have a settlement on Mars in the next 25 years? And how many people think it's never going to happen? Right, I think there's a majority that think we're going to get there. So
Wonderful.
you better get working out how we solve the weight problems and don't lose the
Fundraising.
seeds between those. Ladies and gentlemen, if you could show your appreciation to our panel for an incredibly interesting discussion.
Thank you.
Thank you.
Thank you.